Hello everyone. Today we'll go through 5 examples about geometric sequence and series. In example 1, we're told a geometric sequence has a first term of 4 and a fifth term of 64. We need to find the third term assuming a positive common ratio. First, let's write down what we know. U1 is 4 and U5 is 64. We'll use the general formula for a geometric sequence, which you can find in your formula booklet. Un is equal to U1 times R to the power of n minus 1. Let's replace our values for the fifth term. Now 64 is equal to 4 times R to the power of 5 minus 1. This simplifies to 64 equals to 4 times R to the power of 4. To solve for R, we'll divide both sides by 4. Now 64 divided by 4 is 16. So 16 is equal to R to the power of 4. The fourth root of 16 is 2, so our common ratio is 2. We discard the minus 2 since we know that the common ratio is positive. Now, we can find the third term by using the formula again. U3 is equal to U1 times R to the power of 3 minus 1. So this means that we're going to have U3 is equal to 4 times 2 squared. So 2 squared is 4. Consequently, U3 is 4 times 4, which is 16. So the third term of our sequence is 16. Now, in the second example, we're given two terms. Third term is 18, and the sixth term is 486. We need to find the first term and the common ratio, and we have to find also the fourth term. Now, let's start by setting up two equations using the general formula. For the third term, our equation is 18 equal to U1 times R squared. Let's call this equation 1. Now, for the sixth term, we have 486 equals to U1 times R to the power of 5. This is our equation 2. A great IB exam technique here is to divide the equations with the higher power by the one with the lower power. So we'll divide equation 2 by equation 1. The U1 terms cancel out. For the power of R, we subtract the exponents, so 5 minus 2 is a 3. So we have R cubed. On the right side, 486 divided by 18 is 27. This leaves us with a simple equation, R cubed is equal to 27. Taking the cubic root, we find that R is a 3. Now we can find U1 by replacing R back into equation 1. Now 18 is equal to U1 times 3 squared, which is 9. Divided by 9, we find that U1 is 2. Finally, to find the fourth term, we can simply multiply the third term by the common ratio. So U4 is equal to 18 times 3, which is 54. So our answers are U1 is 2, R is a 3, and U4 is 54. Now in example 3, we're working with a geometric series. We're given that the second term is negative 12, and the sum of the first two terms is negative 8. Our goal is to find the first term and the common ratio. Now let's write down our information. We have U2 equal to minus 12 and S2 equal to minus 8. Remember what the sum of the first two terms mean. S2 is simply U1 plus U2. So we can substitute the values we know into this definition. So negative 8 is equal to U1 plus negative 12. To find U1, we just add 12 to both sides. Negative 8 plus 12 gives us 4. So U1 is 4. Now we need to find the common ratio. We know that the second term is the first term times the common ratio. So U2 is equal to U1 times R. Replacing our values, we get negative 12 is equal to 4 times R. Dividing both sides by 4, we find that R is negative 3. So our first term is 4 and the common ratio is negative 3. In example 4, we are told that 10, x, and 90 are consecutive terms in a geometric sequence. We need to find all possible values of x. The defining feature of a geometric sequence is its common ratio R. This means that the ratio of any term to its preceding term is constant. So x divided by 10 must be equal to 90 divided by x. This gives us an equation, x over 10 is equal to 90 over x. To solve this equation, we can just cross multiply. X times x is equal to 10 times 90. So we get x squared is equal to 900. Square rooting both sides, we get x is equal plus or minus 30. Therefore, we can have a positive answer or a negative answer. So both values are correct. If x is 30, the common ratio is a 3, and if x is negative 30, then the common ratio is negative 3. Example 5 is a classical application of infinite geometric series, which is converting a repeating decimal into a fraction. Now we'll convert 0.27, 27, 27, 3 dots repeating into a fraction. 0.27 repeating is 0.27 plus 0.0027 plus 0.4027 and so on. This is an infinite geometric series. The first term, u1, is clearly 0.27. Now to find the common ratio r, we divide the second term by the first term. 0.0027 divided by 0.27 gives us 0.01. Now since the absolute value of r, which is 0.01, is less than 1, the series converge. And we can use the sum to infinity formula. So the formula is S infinity is equal to u1 over 1 minus r. Substituting our values, we get 0.27 divided by 1 minus 0.01. The denominator simplifies to 0.99, so we can have 0.27 over 0.99. Now we have to get rid of the decimal, so we multiply the numerator and the denominator by 100, which gives us 27 over 99. Finally, we must simplify the fraction. Both 27 and 99 are divisible by 9. Now, dividing both by 9, we get final answer 0.27 repeating is equal to 3 out of 11.